All right, so I'm with Austin today. Austin is a upcoming eighth grade student in North Carolina Public Schools. So I teach seventh grade science, that's my content area. So because Austin's already had this, he also attends a different school. So I'm interested to see the topics that they cover as far as we're going to be talking about genetics, and I want to see what Austin knows from his lessons from last year compared to some of the things that I teach. So Austin, just in your own words, can you explain some aspects of genetics, heredity, variation, things like that?
Okay, genetics. I know you get 50% from the parent, 50% from the mother. There's also certain illnesses that can be transported from certain heredity, and certain genes are more likely to happen than others. Like a recessive gene is less likely if a dominant trait is there.
Okay. All right. So you talked about heredity. And you touched on it. What could you define what it means for something to be heritable?
Heritable means it can be given from the mother or the father or somewhere down the family tree.
Right.
To the
But yeah, so you touched on with the family tree that it's stuff that can be passed on, right?
Mhm.
Heritable traits are things that can be passed on. What do you know about the beginning? So when we first started studying genetics, do you know about the history?
No. Well, a little. I can't remember the names that well, but
Do you
we
remember
touched on
a
them.
name of Gregor Mendel?
Yes, sir.
Do you remember anything? What do you know about him?
He wasn't the one with the bees that discovered that, was he?
He was.
Okay. He basically studied heredity from using pea pods and other plants of that nature and crossing them to find traits that can be passed down from certain ones.
Right. So we refer to him as the father of genetics because he was the first one that really started getting in-depth studies with genetics. A lot of the times during his time frame, scientists were studying multiple aspects. So they would take a parent and an offspring, but they would look at a ton of different characteristics at the same time, which is not a really good practice if you want to study genetics. He was the one that first started, like you mentioned with the pea pods. He looked at traits that were controlled by one single gene. So things like pod shape or the color of the flower were some of the ideas that he was looking at, and he would follow those through several generations.
Got it.
Versus where most genetics studies at that time, they were looking at, like I said, multiple aspects, but they were also only looking from maybe one generation to the next. Mendel was the first one.
Wanted to simplify it into one trait.
And he was looking at genetics that went through many years, many different layers of offspring. I'm trying to get my wording out there. So Mendel worked, and he created compiled this work of genetics study, and we know now that everything that he was talking about was sound. He was a little bit off in some of his wording versus how we use it now.
Yeah.
But when he was alive and he compiled all this, he actually sent his data out into the world to the scientific community. Do you know what happened when he did that? Like, was his findings accepted?
I remember. I don't think it was. But I want to say, I don't know. I don't think it was.
You're right, it wasn't. So when he first sent his stuff out, he was going he was going about things in a completely different way than the rest of the entire world was. So when he sent his findings out, everybody saw it and they were like, some kook up in the mountains, in Austria, some Austrian monk has, spent too much time in a cell by himself and he's lost his mind. This is garbage. So it wasn't accepted. But the way that he went about his studies was picturesque as far as the scientific status of it. He went through everything was repeatable. You could do his same exact experiments and get the same exact answers, which shows you he came to a strong conclusion. So, first, why do you think that his principles weren't accepted? They actually weren't accepted until about 100 years later.
I think it was probably because it was new. None of the scientists think it would be possible.
So what about if you think about that and compare it to nowadays? Because now there's like brand new scientific breakthroughs almost every day, it seems like. Do you feel like it's the scientific community is the same? It's stuff's new. People don't think it's possible, so they don't accept it, or do you think that there's a more wider or larger acceptance right now?
I'd say there's a much more wider acceptance rate than there was back then.
So what do you think the difference is? Like, what's caused that change in the scientific community?
I don't know.
Do you have any thoughts?
Maybe because people have gone back and helped proven that case, so they thought maybe some more things could be possible, so they started thinking outside the box more.
So, if I understand you, so Mendel produced his findings. People didn't accept it. 100 years later, they started looking at his work and they're like, "Oh man, this guy was spot on. He really knew what he was talking about." So, because of those previous times in history when things like that happened and they brushed him off for 100 years, and then they find that out, you're saying that because of people like Mendel, because of those times when they were rejected, and they found out that they actually were true. That's kind of alleviated some of that harshness, I guess, as
Yes,
far as
sir.
judgment. Okay, cool, interesting. All right, well, thank you very much, Austin.
Thank you.
That's painless, right?